Great. So let's get started. So today we are going to see one of the abstract data type stack. Uh, First of all, we'll see what is a stack, what is an abstract data type, and then we will um, go into its application and implementation. But before that, we will also see some problems with array, which is like the motivation for other uh, linked list type of implementation we will have. Okay. So before I start, what did you do in the lab session? Can one of you just mention so that are we parallelly covering the lab part also is what I wanted to check. You can unmute or you can type in the chat also. So what was covered in the lab session?
Measuring time, ma'am.
Okay, so did you implement them in C program?
No.
Yes? I couldn't hear you.
No, ma'am.
You didn't implement in C?
Like we have tried in online compiler only, ma'am.
Yeah, online C compiler. I mean, you will have access to the virtual labs in probably in a day or two, but you can use any. I mean, I asked, did you write? Where you explained the programs and did you try
Yeah, ma'am.
executing it?
It has been explained in online compilers, ma'am.
Okay, okay, fine.
Yeah.
Okay. Okay, so lab team will continue to provide you with details and we can parallelly work on implementation aspects also so that implementation wise you are also thorough because data structures learning has two parts. One is the theory part, understanding how each data structure works, how do you implement them, the algorithm, but equally implementation is also important. Okay, so you have to be very um, conscious of the implementation efforts. So, and mainly your assignments will be based out of labs. So ensure that you parallelly follow the lab sessions. And I can see that very less utilization of the videos are there. So please go through the videos. It's highly essential. They are very meticulously curated information. So ensure that you watch the videos also whenever you have time. Okay. Coming to today's topic, we'll start with problems of arrays, which we slightly discussed in the previous session also. So what is the problem with an array? What do you, when you want to update an array, right? When you want to add an element into the array, 1 minute, I just connect I'll just connect my pen so that I can write also. Okay. So what happens when you want to insert into an existing array? Say, let's say you have something like this, okay? Say I have something like this. If I want to insert at the end, it's not a problem. But if I want to insert at the beginning, okay, and I want to insert in between, uh, it has a high cost of insertion. Say I have a insert which has to happen. Say A is the array name. So insert signature is like this. Insert to an array, A number of elements is say 8 or something, and you want to insert into position number, say let's say 3, and you want to insert the element 28. Okay. Now in this is the array A. This is 0, 1, 2, 3, 4. Okay, then some 4, 8, 5, 6, sorry. Five, 6, 7, 8 is empty yet. Okay. Now if I want to insert at this position, I have to shift it. So how it will come is, so 25, 30, 12 will remain. So you will traverse to this point, right? Sorry, it should be 0, right? So this is. Right, so this you come to this point, then you insert 28. Now you have to move, before you insert 28, you have to move 14 and 16. This is how you have to insert. So this is a costly operation. Similarly, if I have to delete, okay, so what happens if I delete? If I just remove that element, say this is 0, 1, 2, 4, 5, 6, right? So 25, 30. So if I want to delete this element means I have to move the element. So I have to make this as 12, this as 14, this as 16. This is how I have to delete the element. So delete, high cost of insertion, high cost of deletion, because you have to replace the continuous elements. So especially if all the elements have to be continuous, then you have a high cost of insertion and deletion. That's the problem, reallocation. And when the array is full, you want to grow. Remember, I told you about growable array stack also. So if the array is full and I want to have an extended array size, then also I have to copy all the elements from one position to the other position, which will take an operation of order of n. Right? So how do you delete? So how do you delete and insert into an array? So can you tell me the logic? So I will give you a sample array. Okay, let's take. Okay. So let's say insert of A. The size is 6. The number you want to insert is, say, 35 in the position. Okay, so how will you write this algorithm? First, you traverse through the array, right? You traverse through the array. Say this is A. Let's say this is N. This is the element to be inserted, and this is P. Okay. So you run the I loop for I is equal to 1 to P, the P position, right? You please just go I plus plus, right? Once you reach the P position, what you do? You say A of P will be equal to. Can you directly say A of P is equal to this new number 35? Before this, what you should do? What you should do before inserting the new element into an array? Anyone? What will happen
And
if
we
I just
should
say of, yeah, go ahead, sorry.
we should extend the array.
You should extend the array, that is right. But if I just, before copying the other parts of the array, if I just say A of P is equal to new element, that element which is there will be lost, right? So first of all, I have to get the position and move that position to the next place. Then only I will be able to shift it. I have to make that place free, right? So then only I will be able to insert into that position, correct? So I have to shift all elements from this position. So when you reach P, so till P you go I plus plus, okay? And when you reach P, you say A of, say I and P will be same, right? So A of I plus 1 will be A of. So this you have to repeat for all the elements till n. You have to keep repeating them. But here you have to, you cannot start from the P position. You have to start from the end of the array. So we extend. So first element you have to copy will be 50. Next element you have to copy will be 40. So what you have to do, you have to first copy the last element. So you have to go to n and you have to shift all the elements from the last index to last index plus 1. Then once you complete shifting, this place will become empty. So after you complete shifting, what will be, how it will be? It will be 10, 20, 30, and then you will have an empty place 40, then you will have a 50. This is how it will be after you shift. Only when you shift correctly, you will not lose any data. So after you shift, then you can just give A of the position is equal to the new element. But this step you cannot do before you ensure that it is shifted. Right? So now another important point you have to remember here is how do you shift from the, how do you shift in case of larger arrays? So when you insert an element into an array, you have three options: insert at the beginning, insert at the last, or insert somewhere in the middle. So some algorithms or some requirements might give you the position, but sometimes it might be sorting array. So you can use some sorting methods to insert into an array to find where it fits best. So we will see that later. Now our concentration is not sorting. So here we will assume that we know the position to be inserted. So all the position, all the elements which are there above the position, right? Above the position value should be placed. So where you shift all the elements which are greater than the position to its incremental value I plus 1. So once you do that, then it becomes empty. One element becomes empty, right? Now what will happen in case of deletion? What do you have to do in deletion? Same algorithm, delete. If you want to do, what should you do? Say A, 6 is the size, and I'm saying delete the element in position 3, or I say delete element 30. Like, so you first of all, you have to find the element. If it exists, right, you search for the element. And after you search for the element, you find the element, you find the position of the element. Once the position of the element is available, then you replace the next element with the newer element. So what is the algorithm? Let me go step by step to give more clarity. So first, user has to give us what is the key to be deleted. Okay, so let's take a sample array 10, 20, 30, 40. Okay, say the key to be deleted is 30. Okay, now, so now we have to first of all search 30's position. Okay, so we traverse through the array. Right, so when we traverse through the array, we search for it. So for I is equal to, we write a for loop for I is equal to 1 to n. Check if a of I is equal to the key, which is 30. If it is equal, then you store the position equal to I index. Okay, we have got the position now. If position is empty, immediately after the position, if you have found out the position, you can break this loop and come back. If position is not equal to any number, it is empty or it is -1, then the element is not found. So you can say that the element is not found. If the index is having some value, if the position is some valid, okay. So if the position is -1, then you can say element not found. Okay, else, what is the logic we have? What we have to do here? We have to shift all the elements. So say I'm deleting 30, I have to shift 40 to this place. So it has to be A of I is equal to A of I plus 1. This you have to repeat till n. So again here there will be a for loop which runs from position to n, the size of the array, so that you don't have any gaps in between. So this is a deleting from an array. So now what do you understand when you look at these two algorithms? You can see in order to delete is simple. Insertion is delete. I can directly access A of 3 or A of 4 and delete, insert or do it. But if I have to maintain them in continuous location, that is where the problem lies. The cost is high. I have to travel through the loop twice to do that. So if you look at this delete, it will be order of n plus n, 2n times you are actually traversing. Because 1 to search the element, 1 to replace all the other elements. Almost 2n is what is the complexity. So how do you avoid this high cost of recollection of elements? Arrays doesn't suit in such cases. So what do you think is the option we have? First of all, do you understand what do I mean by the problem here? What is the problem with the insertion and deletion in an array? What is high when we delete or insert from an array?
It takes longer time and space for
Cost
larger
of
amount of data.
reallocation
High cost
takes
one.
high cost in reallocation time,
Reallocation.
right? So that is what is the high. So what is the solution to it? Can we avoid this? So that is where another concept comes in. Now, what is the logic behind the array? We are not doing anything very difficult. What is the advantage of the array is they are in continuous memory location, right? So if you know first element, you can easily access all the n elements. So the first, how do you go to the second element? So if A is located in A of 1 or A of 0 is located in the 2000 address, you know that A of 1 will be in 2002 or 2004 depending on the data type, wherever, because you know that they will be in continuous location. So the link between the first element and the second element is very simple. Physically, they are all present together as a group. But because they are present physically, to do insertion and deletion, we have to do a lot of reallocation. So the option is to, what if, hey, I don't locate them physically, I don't map, say I have them randomly. Okay, so this is first block, second block, 3. These are the elements, but logically I map them. So 1 knows where 2 is, 2 knows where 3 is, and 3 knows where 4 is, and 4 knows where 5 is, and 5 knows where 6 is. They are in different memory locations. Say this is in 2000, this is in 5000, this is in some 6,000, this is some maybe 1000. Different place, but the previous element knows where the next element is. This is a logical mapping. Physically, we are not mapping. In an array, it has to be physical, but we know that physical allocation of data is causing us a lot of problems. So we are trying to do a logical mapping. So how this is possible? It's not possible with arrays. Arrays cannot do this because arrays has to be continuous memory location only. So that is where the concept of linked list comes in. So what will happen when, I will talk detail about linked list, but do you understand what will happen so the previous element will know the next element is, but they will not be located continuously. So what will happen? I can easily traverse through the list because the previous element will know where the next element is present. And allocation, what will happen to the allocation, insert, reallocation, insert, delete and all? What I have to change? Say I want to delete 2 and replace say 10. I create a node 10. I just remove these 2 pointers. I have to map 1 to 10 and tell 10 that next is 3. That's all. So only 2 simple statements I have to replace. I don't have to relocate or disturb 3, 4, 5, 6 and all. I can easily do. And if I say I want to replace, I completely want to delete 3 and 10. So 1, what do I have to do? I have to just link 1 and 4. That's all. Very simple. In one step, I will be able to do. So that is the advantage of logically mapping rather than physically mapping. So because of the problems in arrays, we are not able to scale up or improve the cost. It was taking a lot of time for the algorithms to do simple insertion and deletion. And that is why we have different alternatives to do it. Okay. So any questions here? Do you get the reason? Okay. Okay, I'm giving you a small activity. Delete of A is the array, n is the number of elements in the array and position. And delete of A, n, the key. You tell me that time differences. Find out the time complexity for both of them. I'll give you some time. Think through what will be the cost between differences between both of them, which will take longer time. If you can give me order of n also is fine. Or if you're not able to give me time complexity, tell which will take both time, what is the effort. I'll give you 2-3 minutes, think, and then come up with your answer. What is the difference between delete with the position? P is the position, okay? So you have to delete an element at a given position. Here you have to delete an element key. So you have to find out where key is. So tell me which is easier to do, which has higher time complexity, and the difference. I'll give you some 2-3 minutes. So once you are ready, you can unmute.
Delete with position takes less time.
Okay, why?
Because we know the index.
So what do you think will be the time complexity? So after you delete how do you delete actually if you know the position?
We need to shift the element.
Yes. So in this delete of position, what do you actually do? You traverse to the position for I is equal to I plus plus 1 from 1 to position. And from the position, you have to just say A of position is equal to, or A of I is equal to A of I plus 1. Right? That's all you have to do. You have to replace, that's all. But in case of key, what you have to do, I just explained the algorithm. First, you have to do a search. Okay, linear search. That itself takes order of n. Then again, this will take order of n. So it is 2n. So which is better? This is better. Okay, great. Now let's go to abstract data types. Anyone has doubts in this? Clear, delete. If you didn't understand, please let me know. I will repeat again. I hope all of you understand why position is better than with search, deleting with the key.
Yes,
Okay.
ma'am.
Oh. So now let's go to abstract data type. What is abstract data type? We have a data type, what is the meaning of the word abstract is we don't give many details, we hide some details. It is, so when I ask you to do something, you don't have to tell each and every step you have done. You have to give us only the output or what is capability of that, right? So abstract means you're hiding a few details or hiding. It's not basically hiding. You're removing content which is not required. So abstract data type is where data type defines its behavior and the operations that can be performed without specifying the underlying implementation details. So in an array, I say I can traverse through the array. I can say I can delete the array or delete an element in that array. I say insert. I will say the details of all this, but I will not say how I am deleting the algorithm, how I'm inserting the implementation details or the algorithmic details is not given. So it focuses on what is the capability that it can do rather than how it is doing. So it doesn't specify how you have to organize it, whether you have to use an array to implement or a linked list to implement. It doesn't specify how many operations it has to do, what kind of algorithms will be used, whether if it's a search, whether you're using a linear search or a binary search, are you using some recursive functions here? All those details will not be there. Only what is the capability of that data type will be there, which gives a implementation independent view. So in an ADT, it's a mathematically specified in ADT, which has a specific interface, which is nothing but a collection of signature. What is a signature in a function? All of you have studied C programming, right? So in a function, what do we say as a signature? Okay, how do you write a function in C? Can you tell me the syntax? How do you create a function in C?
And first, you specify the data type, like what kind of function. Int,
Okay. Function. So you'll give a name to it here. Okay. Then say, let's say add. Then.
bracket.
Okay.
If you want to give parameters, then you can give it.
Okay. So if say, let's say I give add. Okay. Then I write the logic for the function. Right.
Yes,
Then I
ma'am,
have
like
a
return A plus B.
return A plus B, or if I have taken some temporary variable, I return that, right? And what is the return type? Also, you mentioned, no?
Yes.
Right? So what is the signature? This part, int, the function name, function with, I'm not using exact syntax, I'm telling the logic, okay? Don't follow. The add A comma B. So this gives the entire details about the function. What is the return type? What is the function name? What are the parameters it requires? It doesn't tell us how have we implemented the logic. It doesn't. So the signature is an abstract view. Signature is detailed about the function. So this particular specific interface will have what are the functions or what this signatures, what are capable in an abstract data type. And it will also have a set of preconditions and post conditions you have to check, which defines the semantic of the operation. You cannot return A and B or add two numbers if A and B are not integers. Right? So you have to check when A and B is received, you have to check whether is A a character or if A is a integer, etc. Then only you can add A and B. If it's a character, you're not going to add them. So those are the preconditions and post conditions which should be available, which defines the semantics of the operation. So this ADT should contain a collection of signatures which tells us the operations which can be performed. So if calculator is an ADT, I will say add is a signature, subtract is a signature, multiply as a signature, etc. Then I will have a set of axioms, right? So preconditions, I will say A, B, they have to be an integer. So I will have a function which checks is integer of A, whether it returns true if the parameter is an integer. It will return false if A is not an integer. And post condition, I check whether maybe have I returned a valid integer or whether it is empty. So preconditions and post conditions define the semantics of the operation. So this is what an ADT will contain. So now I show you one ADT, right? So stack, I will talk about stack in detail, but you can see the stack operations are push, pop. So this is the signature for push. So push will push whatever element you are mentioning in this. Pop will give you, pop out the last inserted element. So you can see that there is no return type for push because it doesn't return anything. There is no input parameter for pop because it is not going to take any input from the user. It is just going to pop out the last inserted element, that is return the last inserted element. So it is a output, the type is there. So from the signature, you are able to understand what are the input parameters, what is the name of the function or the name of the operation, what it returns. So this is the main interface. Now, apart from that, you also, so top is another object. Now, these are the other axioms is empty. If there are no elements, how will you insert? Or if the object is empty, how will you insert an empty element? So you have to check for certain axioms, the preconditions and postcondition. So in order to pop, you should first check whether it is empty. If it is empty, you cannot do pop, right? And you want to know the maximum elements in an array, then it is another stack operation size of. So this is what ADT will tell us. Here it doesn't tell us how push happens, how pop happens, how do you calculate the size of a stack. No internal implementation details are available. Only the abstract data types is available. So that is what is called as an ADT. Okay, so for every data structure we are going to learn, we will look at the ADT in detail. Okay, so in any questions on ADT, I will show you a sample ADT.
No, ma'am.
Okay, fine. Just pulling out the sample ADT from the book. Just give me a second, it's taking a little time to open. Just give me a second. The PDF of this thing is not opening from the online library. I will see if I can take out a. Okay, fine. I will just explain ADT now. I will maybe during the break, I will try to pull out the other things. Okay. I wanted to show you a stack ADT. That's what from the book itself. Fine. So now you understood what ADT will contain, right? They are way of encapsulating. It is a way of encapsulating what is available on the data side, data type side. So it gives us exact operations without specifying how operations will be implemented. So data abstraction, modularity, all these are encapsulation is the concept. Now, if you look at the ADT, so let's say you have a application program. Okay, say you are implementing a web application or some application. So you have an application program, right? This application program will interface with the abstract data type. Okay, so let's say this is the abstract data type, the ADT. This will the application program will talk to the ADT with the interface only. The interface, what is the interface? What are the functions which are available, etc. So now to the in the ADT, so there will be the list of functions which are available, and there will be list of public functions, private functions which are available to the interface. So this application program will have visibility, or the interface will be there to connect only to the functions, etc. But underlying, you will have the data structure and the memory management. You might have implemented this in a array, or you might have implemented it in the linked list. You might have the memory, all that. So this implementation is what is actually the function will use. But this part will not be visible to this application program. So that is the idea with ADT. And this when you learn object-oriented programming in the next semester, you will learn how to implement this in Java and other places where you hide complex implementation details. So here in ADT also you need to understand that allows how different internal implementation. Say I want to change from an array-based implementation to a linked list-based implementation. I can easily change this without even the application program being aware of it. So that is the advantage of abstraction. We can use primitive values like int, float, character without with the understanding that these data types can operate and be performed on without any knowledge of how they are implemented. Okay, I know how to insert a character element into a stack. I know how to remove a character element from an array, but I don't need to know how they are implemented, how it is happening in the backend. I can just use them as it is. That is what is an ADT about. Okay. So let's understand first stack. Where have you heard about this word stack before? In real life, have you heard of this word stack anywhere? Where do you use stacks generally?
In book of stack.
A book of stacks, that's very good example. Yes. So why do you say a book of stacks? Why don't you say a list of stack? Or why don't you say a bunch of books? Why do you say stack? Any idea?
And books are arranged in, they arranged in on top of each other.
Okay, they are arranged one above the other, probably.
Yes.
Yes. So that's where you say them as stack. So now when you have a book arranged one above the other, right? Say you have the first book, then you have the second book. This is how they are arranged. So this is what we call it as a stack of books, right? Now, what is the problem with this stack of books? If I want to take out, I can easily take out the last book, right? Which I placed. But if I want to take out this book, right? I have to remove all the above books and then only take the book. So what does it mean? Stack is nothing but a container of objects or a group of objects, but they are positioned one above the other, or they are inserted in such a way that they can be inserted and deleted only in the last in first out option. So if I want to take out this, I can only take out the first book. Without taking out the first book, I cannot take out this book. Without taking out this book, I cannot take out this book. Okay. Now, say I have this, say this is book 5, book 4, book 3, book 2, book 1, right? If I want to take the third book, I have to remove 5 and 4, right? The last inserted element first. So the last in first out is the principle which is used. So only the last inserted element can be removed, but you can also remove more than one last element. So I can at a time take B5 and B4 together. So that is, I'm doing two pops together. So I can take B5, B4 together and place it here. Right? I can do that. But without taking B5 or B4, I cannot pull out B3. That is what I mean. In real life, you can just hold the book and pull out one book depending. So that is not what we are talking about. But in practical, in a system, etc., you have to take all the books on the top and then only you can take 3. So only the last inserted element can be removed. So when you want to add an element, so when you want to stack a book, what you have to do? You want to add, you can only insert at the topmost position. So push is inserting an element into the topmost position. Pop is only removing the last inserted element. You cannot insert in between. Okay, so that is about stack. Now, where is the real-time use? So in real time, we have stack of plates, stack of books, that's what I say. So when I say, please stack the boxes by the door, what I'm meaning? What do you understand by this statement? Please stack the boxes by the door. When I say, please stack the boxes by the door, what does it mean?
I'm adding the boxes by the door in the top of the
Arrange the boxes near the door on top of each other, right? So when I say stack, you're like, you have to place them on top of each other, right? So that's what the exact, similarly the same. So you want to remove, you have to remove the first box only. So the removing is called as pop, inserting is called as push. Now, so this is real life use. In software, where it is used? Undo, redo. What is undo, redo in Word? What do you do in Word? So you type something, right? So if I have to undo, what operation I have to undo? The last done operation only, right? I should not undo this operation. Say I write first line, then I write some second line, then I write some third line, fourth line. And here I say I want to, this I made to bold. So when I do undo operation, what it should do undo? This point only it should undo, right? So the software, the word processor should be aware of what is the last inserted action. So it should always point to the last inserted action. Say this is undone. Now this is removed. Now what is the again another undo means? This step has to be undo. Right? Now if I have to redo, so this, if I do this and I have to say redo, what will happen? I have to redo this step. So undo and redo is where stack will be highly used. And browser history. So you are in the home page, then you go to dashboard page, then you go to contacts page, right? Or you go to say, then you go to some products page, something like that. Now, if I have to go click back from this, it goes to contact page. It should not go to home page, right? And when I do forward from this, it should go to the products page, not the contact. It should go to the dashboard. So how do I manage this forward and backward? So that is again an example of a stack, because from the last element, it has to go to the previous element, and always the last element is what should be on the top. And string reversal stack can be used. Function call stack. Have you heard of recursive functions?
Yes.
Right? So recursive function is a function which calls itself, or any function which calls itself, right? So I have function 1, say f1, then I have which calls f2, right? Say this function f2 should and then this function f2 calls f3. Okay. Now this f3 function should return to f2. F2 function should return the value to f1. F3 cannot directly return value to f1, right? So how do you maintain this order? Function call stack again uses stack. Okay, that's why it's the name itself is called stack. So this is the advantages of using stacks. Okay, so we'll see how to implement it. Okay, so we'll take a short break now. It's 12:10. So quickly take a break and come back. We will see after the break, we will see how to implement a stack using arrays. Okay, but array implementation, I'm just giving you for understanding only. In practical real life, we will not use stack array implementation much because of the problems I discussed at the beginning of this session. We will always use linked list implementation only to the maximum because of the advantages it has, because otherwise it's high cost when you use an array implementation. But first we will, because you should have an understanding, first we will do a array implementation of stack, and then we will do a queues, and then we will go to the linked list implementation. Okay, so please take a quick break and come back. We will continue. Okay, let's continue. Okay, so first let's look at how to implement a stack using arrays. Now create a stack. Let's say the maximum size of our stack is n. Okay, so the stack consists of an n element array and an integer variable t, the index which represents the index of the top element in an array. Okay. So the array starts at 0 and we initialize t to -1 so that whenever a new element is inserted, it is increment. The t value is incremented. That's what we are going to do. So initially t will be -1. Then whenever an element is inserted, it will insert into 0 and t value will become 0. Then another element is inserted, t will become 1. So t always represents the index of the top element in an array or in a stack. So push, pop are the major functions. And then we have some other simple auxiliary functions. So first let's look at push. If size of is equal to n, then return error, which means size of will return t plus 1. Okay, because we are why t plus 1? The maximum array size is only n. Okay, so we can store only n elements. So the index will be till only n minus 1 because the array starts from 0. So t plus 1. So what is the current size of the array? So if t is 10, the current size of the array will be, that is number of elements inside the array will be 11. So that is why whenever you want to find out the number of elements, it is always index plus 1. That is the number of elements in the stack. So returns t of 1. So if the size value, this is returning, say if it returns anything equal to 1, right? We cannot add any more. If it's equal to n, which means that we cannot add any more to that stack. So that is why it returns error. If the size is not equal to n, we can insert the top element. So t will become t plus 1. So if t is here, it will become t plus 1. And into this s of t, you insert the element. The element to be inserted is O. Okay, so this is what is push. So you will have only access to t. You will not. So if you carefully observe push pop algorithm, you don't use s of I or s of index or s any other. You use only s of t. That is what is how you implement a stack. Because in stack, you should always have access only to the top element. You shouldn't do any operations inside the other elements. Now algorithm pop, if you want to do, right? So first of all, for you to pop out an element, what is mandatory? There should be some element in the stack. If the stack is empty, we cannot pop out anything. So that is why if is empty function is used. So is empty, whenever the stack is empty, t will be -1. So if t is less than 0, it is true. So if is empty is true, it is an error. You can say no element in stack. If t is not empty, then you can remove the top. So say t is here. You remove the top element. You make t point to this element, right? And you return the topmost element. Okay. Actually, you should return t right here. Why I'm returning? Let's take an example. I doubt it is wrong. This is copied from the book only. Let's take a stack. Say t is equal to -1. Okay, let's first push of 5. So push of 5, what will happen? T will become 1, 0, right? And 5 will be inserted here. Okay, then I will again do push of 10. T will become 1 and 10 will be inserted here. Then I will again do push of 50. T will become 2 and it will be inserted here. So T is 2 now. 0, 1, 2. So this is T. Now if I do pop, right? So T becomes T minus 1. So 2 minus 1, T becomes 1. And I should return what? I should return T only, right? S of T. Why it is T minus 1? I think the statement is incorrect. Okay. So it should return T, the topmost element. So 15 only it should return. So what you should do, you should copy this element in an array. So you say the topmost element is returned, pop, remove that element, right? So you copy the element to be S of T equal to this top element, and then you say T is equal to T minus 1. So which means T position will come here and this element will be removed from the. Okay, so this is what you should do. Now what is top? Top is nothing but it is only a read only operation. It is push and pop only. Push inserts, pop deletes. Okay. Now if this has to read, you don't have to delete, but you want to read the topmost element, which is there, then you can read S of T. Okay, if it is empty, it will return error, but you can read S of T. So here also you should read, use stop, return the element, and then delete it. Okay, so that is what is essential if you want to read the topmost element. Okay, so is it clear what is size, what is SMT, what is stop, what is push, and what is pop? So in push, it adds element on the top of the stack, right? Now, if you look at the time complexity for each of this, what is the time complexity for push? Can anyone say? What is the time complexity for push? Calculate. What are we doing there? Primitive, or so how many steps are there? 3, 4 steps are there, no? So this is what? You're calling a size of function which returns 1. So this is our statement is also 1, right? So 1, 1. This is simple calculations. Maybe you can say 2. This is also simple a lot assignment. So you can say 1. So it's a constant. So say it is 5, right? It is a constant value C. So it's an order of constant. So in asymptotic complexity, we say it is a constant which is order of 1 or order of C. Okay. Similarly, pop also you see, this takes 1 unit of time. This also takes 1 unit of time. This may take 2 units of time, or this might take. So this is incorrect. Okay. So you take 1 unit of time. So again, this is also order of 1. So you can see that push pop, both of them, insert and delete from a stack, is not dependent on the size of the stack at all, right? It is not dependent. You don't traverse in an array. What you do when you want to traverse, insert an element, you have to start from this position, go through all the position, and then add. So it takes order of n. But you can see in a stack, it takes only order of 1 for push as well as for pop. Okay. So it adds an element on the top of the stack. We have reference to the top of the stack through T. So it just takes order of 1 time because we know where it has to be inserted. There is no need to shift elements to make new room for element like in an array. Similarly, pop also, it removes the element on top of the stack. So this also takes order of 1 time because it has the index of the most recently added element. And top also, if you say, it returns, it's only a read operation. It returns the topmost element value. It is also a constant time operation. Now, what is the difference between pop and top? Can any of you tell me? What is the difference between pop and top? Both we are reading the topmost element only, right? But what is the difference?
Top is the first top element. Pop will remove the top element from the stack.
Yes. So top only reads the topmost element. It doesn't do any deleting. Pop, what it does, it reads and deletes also. It returns the topmost element, but it removes the topmost element. So after pop, there will be a change in the array. So if you have, say, 5, 10, 15, 20, when you do top, it will return 20, but the stack will remain same. But when you do pop, what will happen? It will read 20 and it will remove 20. Now next top element will become 50. So pop is 2 operations, reading and deleting, whereas top, it is only reading. That is the difference. Okay. Now, what is the advantage? It is stack is a linear in data type. It is last in, first out, right? It can be implemented with array or linked list. So in case of a linked list, what we will do in linked list implementation, I will explain in some other session. But what we will do is we will not have continuous memory allocation. We will store them as logical allocation, right? And what is the advantage of using an array in a stack implementation? No extra memory required to store the pointers, because in linked list, what you have to do? You have to map, right, from this element to this element, from this element to this. So that memory is not required, right? That is the advantage. It's simple to implement. But what is the problem? The size of the stack is preset. So when the size of the stack is n, right? If it reaches n, we cannot store anymore. So you have to again do the growable stack concept, remember, which we discussed. And then we have to start from new, which is order of n. So that is the disadvantage of using an array implementation. The array implementation is simple and efficient because it has order of n everywhere. But the problem is the upper bound. Sometimes it might be, we might keep a very large value, which is waste of memory, or we might select a small value, which might not be sufficient. So very often we have to replace it with a growable stack, right? So what is a growable array-based stack? As I already explained to you, when the array is full, instead of throwing an exception, we replace. So in this case, right, when size of is equal to n, what we show an error. But in a growable array stack, what we do instead of throwing an error, when the size becomes n and the stack is full, we replace, say this is my stack. Okay, say it can hold only 3 elements. Okay, and if I want to insert another element, I create a new stack with double the size of the existing stack. Okay, so and I copy all the elements and I also insert a new element. So that is what is a growable array stack. What is the incremental strategy? Increase the size by a constant, always increase plus 10 or plus 20 depending upon your application, or use a doubling strategy where you double the size of the stack, whatever you already have. So I showed you an example of doubling strategy. So whenever the push is happening, if T is of S length minus 1, that is T is already is the maximum size of the array, then you create an array in a new array size. So either use doubling strategy or incremental strategy and create a new array. Copy all the elements of S to array A. And then in the new position, T is equal to T plus 1, insert the new element. So these are the 2 steps we generally do. Right? This is what we generally do. And if the size is full, we return error. In this case, what we are doing, if the size is full, we create a new array. This block is what is different. Okay. We create a so this is what is the extra step. Okay. In that normal push, we show as error. Right. In this, instead of showing error, we are creating a new array, copying all the elements of the existing stack to the new array and replacing it. Okay. So, and then we are repeating the normal push steps, which we already do. So this is called as a growable array based stack. Whenever the application size, the array is completely full. So the array implementation is simple and efficient, right? But what is the time complexity for growable stack? What is the time complexity for push here?
Constant.
Sorry?
Constant.
Constant, not constant in order of n, right? It's not constant. It will every time dependent on number of elements. So it will be order of n because you have to copy all the things, right? So that is the disadvantage, but you can be a little sure, but because this is not going to happen every time, right? So if n elements are there, you will insert n elements, then again, so it will be order of 1, order of 1, order of 1, right? And one time it will be order of n. Then again, it will be order of 1, order of 1, like that only. And after some time, it will be order of n. So it will not be exactly order of n every time, but in a growable array stack, sometimes it will be order of n. Okay. Now let's look at some of the application. As I told you, balancing I have to explain in detail. I will explain. Undo, redo features, forward, backward buttons. It is used in many algorithms like Tower of Hanoi. Have you heard of this Tower of Hanoi problem? When you learned recursive functions in C? Yes or no?
Oh, no.
No. Okay, fine. I will explain it. Okay, it is used in a lot of Tower of Hanoi tree traversals kind of problems. Okay, and in memory management, in stacks and all, it is used. String reversal is also another application of stack. We will see some of these applications in detail. Okay. Do you know postfix, prefix of expressions? In maths, you would have learned, right? In your school.
Yes.
Okay. So what is postfix? Let's take a very small example. If I say A star B plus C, what is postfix? How do you do postfix? So first you do multiplication, right? So it will be A, B star, then C plus, right?
Yes.
Is this right?
Yes, ma'am.
All of you know how to do postfix or no? Only Sri Vignesh is answering. What about others? So prefix, what you do for this? It will be AB star, then it will be, right? So for postfix, prefix, balancing parenthesis, right? Evaluate postfix algorithms. All this is an application for stack. Okay, I will talk about balancing parenthesis. So a bracket is considered to be whether it can have a parenthesis or curly brackets or a square bracket. Two brackets, if it are considered, it is to be a matched pair. Okay, if there is an opening bracket, like parenthesis, square bracket or curly bracket, which occurs to the left of the closing bracket of the exact same type, that is a pair. Okay, so let's say we have a complex equation. We don't know whether all the parentheses are paired or if there is any missing balancing of the parentheses. That's where we create a algorithm to do that. So how do? We use stack here. So declare a character stack yes. Now traverse the expression string. Okay, if the current character is a starting bracket. Okay, if the current character is a starting bracket. Okay, let's take this example only. Let's take A star B plus C. Okay. Okay, so this is my equation. Now, if this current character is a starting bracket, then you push it to stack. Okay, let's write a stack here, create a stack here. Okay, so this is my current stack. So first element, I push it to stack. If the current character is a closing bracket, you then pop from stack, and if the popped character is the matching starting bracket, then fine, else parentheses are not balanced. Okay. After complete traversal, if there is something in a bracket, right, left in the stack, then not balanced. Okay. So we start from here. If the current character is a opening bracket, I insert. Then again, the next character is also opening bracket, so I insert. Right? I can print those values which are not brackets. So A star B, I can just ignore. Then I come to the again parenthesis. So this is a closing bracket. So what I do, if it's a current character is a closing bracket, what I have to do? I have to pop from the stack. So I pop means the last element. This is T, right? So it will pop out this. So this and this, the current character are matching, right? It is matching. So it is balanced. I repeat, I go back. Again, read the next one. So this again is a closing. So this is already removed. So now T will be here. So I pop that out. So this is also matching. So the character after traversal, if there is some starting bracket left in the stack, then it is not balanced. But after everything is empty here, so this is a balanced equation. Okay. Now let's take an unbalanced equation. let's take something like now what happens? First, I will insert this one. I will insert this one, right? Now, when I pop whenever the closing bracket comes, right, I will pop this out. So this will not match this. Okay, so it is unbalanced. So we are using stack to balance parenthesis. This is the example. Okay, now we will do a postfix evaluation. Okay, so we are creating a stack to store the operands or values. Scan the given expression so that when you pop out, you get a postfix value. Okay, scan the given expression and do the following. If the element is number, so let's say example of again A star B plus C. Okay, if the element is a number, push it to a stack. If the element is an operator, pop operands for the operator from the stack. Okay, so if and evaluate the operator and push the result back to the stack. Okay, and when the expression is ended, the number in the stack is the final answer. We will do an example for this. Okay, so our expression is this. Okay, so we have to take a postfix expression. Actually, I took by mistake. We have to evaluate postfix expression. That is where stack is used. Okay, so this is my expression 4, 5, 6 star plus. So what does this mean? It is 5 star 6 plus 4. This is the expression. The postfix is 4, 5, 6 star plus. So we will use stack to evaluate it. So if it is a value, so remember these steps. If the element is a number, push it. If the element is an operator, pop out the operands. Okay. So how many operands do you pop out? How will you decide that? Here, if the element is operator, it says pop operands for the operator. But how many operands? How do we know? For which operator we will have 2 operands and which operator we have 1 operands? How do we know? Binary operator, we should know which are the operations, how many operands are required. So for addition, we need 2 numbers. For multiplication, division, subtraction, we need 2 numbers, right? For increment, decrement, left shift, and all we need not have. It's a single operand operation, single operands, right? So that based on that only we will decide. So now we push 4, we push 5 because 5 is also a number. We push 6, 6 is also a number. Now we have star. So when it comes to multiplication, since multiplication requires 2 operands, we pop twice. So we pop 6 first, then we pop 5 because 6 is on the top, right? So 6 first and then 5. And then you do the multiplication, you get 30. Now you insert 30. So if the element is an operator, you have to pop the operands, evaluate the operator and push the result back to the stack. So we have pushed it to stack. Okay. Now again, we have to read plus. So it is because plus you have to pop twice. So you pop out 30, then you pop out 4. So you do the math 30 plus 4, 34, and you push to 34. When the expression is completed, you can see the final result in the stack will be the only element in the stack will be the evaluation value of that particular expression. So this is an algorithm for evaluating postfix expression. Okay. So these are the steps. Input, push 4, stack value is 4. Then again 5, push, stack value will be 4 plus 5. Then again 6, you push, stack value will be 4, 5 and 6. Then again you push, you start, since it's a operator, you pop out two elements. So 5 and 6 are popped out and you calculate it. You again push that result. So the stack is 4, 30. And then you have plus. So you pop two elements. It is empty. So 4 plus 30. Then you again push the result. So no more elements in the operation. So you pop out the final result. Okay. Now I'm going to give you an example. You have to tell me the steps for this. Okay, let me give you a very simple example. Okay. So tell me step by step. Step 1, step 2, step 3. So what is the first step? What we will push? Push or pop first step? You'll push, right?
Yeah, push 8.
Push 8. Okay, very good. So stack value, let's make it here. So it will be 8. Then next step.
Push 2.
Okay, push 2. Okay. Next.
Push 3.
Right. Okay, now fourth step.
When pop 2 values, 2 elements.
So pop two values. So we will get 3 and 2.
2.
Now what we have to do? We have to evaluate. So 3 plus 2. So we get 5. So we pop and we evaluate. Now what we have to do? So the stack will become, now only 8 will be there because we have popped out. So, and we calculate 3 plus 2 equal to 5. Now what we have to do?
Now stack value will be 8, 5. Now we need to pop 2 elements and evaluate.
No, first you have to push 5.
Yes.
Yes, after evaluating 3 plus 2, you will push 5. So this will become 5, right? Now you go back to this plus. So because plus is there, you have to pop again. So you pop 5 first and then 8 first. You evaluate 5 plus 8, 13. And then you, in the 7th step, you push. So this both will become empty. So the stack will be empty now. So you push 13. So 13 will be there. So no more elements there. So the result will be, to read the result, you can read the topmost element, which is 13. Okay.
Yes.
Okay. Now, what is the time complexity of all this? It is only simple, right? Push, pop and all. It's just 1, 1, 1 because we are not doing it. Only search operation is difficult, but we generally don't do search in stack. We don't use search for a data structure stack for searching. So otherwise it's all single digit operations. So I will go to queues now. Any questions in stack? No, right? Shall we move to queues? Okay. So now what is the difference between queue and stack is? Queues will use first in, first out principle. So we have a array, say we have an array. You will insert only to the last and you will remove only from the first. Okay, so if I have to insert an element, I will insert. After 5, I will insert 6. After 6, I will insert 7, 8. If I have to remove, first I will remove 5. In stack, we will remove 8 only, right? But here we will remove 5. After 5, 6 will become the first element. So after 5, I can remove only 6. After 6, I can remove only 7. If I want to insert, I can remove only at the back. So Q differs from the stack by following the first in, first out principle. So this element which was inserted first at any time, only that element will be removed. Elements may be inserted at any time, but only the element which has stayed longest in the queue will be removed. Okay, so elements are always inserted at the rear end and elements are always removed from the front end. So inserting is called as enqueued. Removing or delete is called as dequeued. So now what is the ADT for queue? You have an empty queue. That's to create a new queue, new empty queue. Then enqueue is like you have a, say this is our array. You have the element to be inserted. It inserts here at the rear end. And when you want to remove, you remove from the front of the queue. So it is dequeue. And if you want to read, which like we had top, no? So this is like push, this is like pop, and this is like top. So if you want to read the frontmost element, you read. So like top, front will only read the element, but does not remove the element. Okay. So enqueue of object will insert an element at the end of the queue. Dequeue of that will remove and return the element at the front of the queue. So it has a return type. It doesn't have input parameters. This doesn't have any return. And other than that, you have the size is empty and front. Front will only read the element without removing it. Size will return the maximum number of elements which are stored. And is empty will check whether there are elements which are stored. So attempting an execution of dequeue or front will show an exception. So you always have to check whether it is empty before doing those operations. I will come to the disadvantages after explaining the queue implementation. Okay. So first examples where it is used: waiting lines, first in, first out, queues in our hospitals, queues in ticket counters, all that waiting lines depend on queues. Access to shared resources. For example, when you give printout, what happens? The first object you gave, that is only printed first, right? So that is an example of a queue. Whenever you have multi-programming, when multiple processors are waiting, the first in, first out is the option which generally is followed. But there are other methods also, round robin fashion or least time first, all that. But generally, first in, first out is used as a first easiest method. Okay. Now let's look at an implementation. So whenever there is a queue, you create a queue using an array. A maximum size n is specified. So that is the maximum amount of value, the queue value it can store. So there are different indexes you have to maintain. There in stack, if you remember, we maintain only one index because the insert and delete happened both from the one side only, on the top position only, right? But here you have to insert at the rear end and you have to delete from the front end. So that is where you need two integer variables, one for the front end, one for the rear. So F represents the index of the front element, which will be you always removed. And R represents the index of the element where more elements will be added. Okay. Now, initially F, R, everything will be 0 when the when the queue is empty. Right? Say we have initialized it. So it's 0, 1, 2, 3, 4. Okay, we have initialized it. Okay, so this F is equal to R is equal to 0. Okay, now let's insert a new element. Okay, so how do we insert a new element? F will remain 0. Okay, R is 0. This is what it is, starting position. Say I want to insert 10. Okay, say this array is Q. Okay, now Q of R will be the element I want to insert, say at 10. So this becomes 10 and R will be R plus 1. So now this F will remain here, but R will become. Now I say I want to insert 20. Now again, Q of R will become 20 and R will become R plus 1. So R will move from here to here and this will be 20. And say I want to remove an element. Okay. So to remove always happens from F, right? So I read whatever is there, Q of F. Okay, I assign this is the element I want to remove. So I read the value of it and I say F is equal to F plus. So F will become this F. Okay, so like this, the Q will be growing in size. Okay, now if F, say I want to remove again. So I want to remove again means I will remove 20 and I will. So F and R, if they are equal, what does it mean? There is no elements in the Q. It is empty. That is what, if F is equal to R is equal to 0 initially, and the Q is empty whenever F is equal to R, because there are no elements in the Q. Now there is one problem with this Q, which I will talk about in detail in the upcoming sessions, but I will just give you an idea today. What will happen if I keep on doing this insert and delete in an array implementation? Okay, let me give you an example, okay? All of you create an array of size 10, n is equal to 10. Okay, remember we have this NQ, DQ, front. These are the operations we have. Okay, front, NQ, DQ, front, size is empty. Okay, now what will happen? Say, okay, so F is equal to R is equal to 0. This is the first. So I do NQ of 10. Now what will be the value of F and R? Tell me. Let's keep this small, okay? Let's keep n is equal to 5. Okay. So when I do NQ of R, what will, sorry, NQ of 10, what will be the value of F and R? Can one of you tell me? NQ of 10. What will be the value of R? R is equal to R plus 1, right? So it will become 1, right? And here 10 will be added. Right? Now I do say NQ of 20. R will become 2.
2.
NQ of 30, R will become 3.
3.
Right? So F will remain here. Okay. So let's say I now ask you, so say this is there, okay? R is here. Now if I ask you to DQ, then what will happen? DQ means what will happen now? You will read this value and F will become here. This will be removed. Correct?
Yes.
Okay. F is 1 now. Okay. Now let's say we again do, let's say we again do DQ. What will happen? So this will be removed. So F will be here. Let's say we again do, we do NQ. So I will say insert 40. Okay, R will become here. Now again I do 50. Okay, R will become here. Right, now R is here in the last position. So say I want to insert 60. Can insert here. But what will happen? R will be R plus 1, which will be the final. There will be no position for this. Now, if I do DQ, if I do DQ also, F will move from this to this, right? Now only 3 elements are there, 40, 50, 60. For a n is equal to 5 or n is equal to 6, say, there is only 3 elements, 3 positions are empty, but still because of this logic of increment R and F, your maximum size will be reached. So you will not, if the, because this empty or this size will return the number of elements. So when you mention that F is equal to R and DQ n times, right? If you keep on DQing n times, this particular shaded portion, right? This will move and it will reach n and you will not be able to use it at all. So that is a disadvantage. So in a simple queue, if you completely NQ and DQ n times, you will reach n and no more elements can be added, though you have a lot of available space. So actually you had so many empty spaces here, but you cannot use that because of frequent DQ and NQ operation. So what can we do to solve that? You have to create a circular queue, wrap around the end of queue. So that is where the circular concept comes in. Where what do? You kind of hold this. So after this position, if there are no empty positions, it goes and checks in the first few places if there are empty positions. So after R is n minus 1, R will become 0 again. If this is not having any element, if it's empty. If it is having an element, if F is already, F is 0, then it cannot happen. But if F is say 5 or 6 like that, this place is empty, then R can go and increment like here. It can happen that way also in a circular queue. Okay, so that is a concept which I have to explain in detail in the next upcoming sessions. I will do that. Okay, so far is it clear? What did we look at today? Stack, array implementation of stack, and simple queue and implementation of queue. Okay. So I will stop with this for today. So any questions till today, whatever we covered today, please ask. Any questions you have, any of you? No?
Just one question I have.
Yes.
Will you explain this last topic in detail in next class?
Indeed. Okay. Sure. Yeah, I will explain in detail. Again, we will do with an example. Okay. So basically, it is like you have 10 sockets, 10 holes. Okay. You can put one ball. So now you can always take the first ball only. That is what is the idea. So let me share. Next class, I will explain with the maybe example. But to tell you the concept alone, very simple concept, I will say. Say you have 5 empty boxes or empty bowls. Okay. Now you can only fill in order. So you are filling this bowl, you are filling this bowl, you are filling this bowl. Okay, now this bowl, you are emptying it. So this becomes empty. Okay. And you are again emptying this bowl also. Okay, now when I fill this bowl, I can fill only in this bowl. I fill this. I fill this. Now you want to fill more bowls, but because of the implementation, what you have, F and R has reached the maximum limit. So you are not able to fill because you have the bowl here. So now actually I have some empty bowls allowed. So I can go and fill here also. If R can come from here to here, I can go and fill here also. Right? Though I have 2 empty slots because of the algorithm going incrementally, I'm not able to do that. So if R will reach maximum N and it cannot go back to that. So that is where if R can again go back to 0. Okay, 0, 1, 2, 3, 4. So if R reaches maximum N minus 1, we are stopping the, but if R can go back to 0 also, it is possible that you can fill some of the empty places, right? So that is what is a concept. So when you want to connect the last element and first element, you are actually creating a circle. It is like if you have a rectangle, empty box, and if you want to have, after the last box, you want to add to the first box, you are kind of creating a circle. So that is what is a circular queue, which I will explain in detail in the next session.
Okay, got it.
Yeah. Okay, then thank you all. Bye. We'll meet again the next session.
Okay, bye.
Thank
Thank
you.
you.
Thank you, ma'am.